Hi everyone, today me and Joe are going to present our project, Unfair ToS, the LLM Unfair Contract Term Detector. So terms of service are legal agreements between service providers and users that is usually complex and lengthy with legal words that can be difficult for the users to understand. And understanding the terms is important because it could lead to some potential problems, like users may unknowingly accept their terms which can limit their rights and even raise some privacy issues. Therefore, we are employing large language models to solve this problem. And for our detector, the first step will be to highlight sentences in the ToS documents that requires user attention. Then we will simplify the highlighted sentences. And finally, we will categorize it into either fair or unfair and provide a reason if the term is unfair. And we use two datasets for our project. The first dataset is used for text highlight, and it's adapted from the website called Terms of Service Didn't Read that contains over 1,000 ToS documents. And there are contributors that can highlight important sentences with approvers validation. And we're gonna use it as an input data for prompt engineering and also serving it as a ground truth for evaluating GPT's performance. And there are two main issues with the dataset. The first thing is that it has too many data. So we have narrowed it down to 300 sentences from 11 documents. And also we have cleaned up the data to make them uniform and also get rid of extras like special symbols. And the second dataset is used for text classification, where it's adapted from a paper that contains 100 ToS document. And we noticed that there is a significant imbalance between the fair and unfair terms, which is expected. So we have put the unfair terms into 4 main groups and applied oversampling to balance the dataset. And here's an overview of the architecture for the project, which has 2 main components. So the first part is for text highlight and simplification, where we feed the clean terms of service into the GPT-4 model and use special prompts to make it find the key terms. Then we ask the model to simplify these sentences so that it can be understood by the users. And we have used few-shots chain of thought prompt engineering for this, where we first to make the model think step by step, and then we provide specific examples of the key terms that is based on the 57 categories from that ToS Didn't Read website. And finally, the highlighted sentences that was identified by the GPT-4 model will then be categorized into either fair or into one of the 4 unfair categories using a fine-tuned Hugging Face GPT-2 model.
To evaluate the result of the type highlights, we use the ground truth as the highlight center from the ToS Didn't Read website, and use the baseline as the text rank, which is unfair, unsupervised unsupervised ranking algorithm, and to measure the precision required in the F1 score. As we can see from the upper right, our GPT model outperforming all 3 metrics, and some documents show has a really big difference between these 2 models' F1 score. However, the GPT-4 does not have a really good precision using the website as the ground truth, but the website is not 100% correct since human have bias. And there is some important sentences that are only been highlighted by the LLMs. For example, service provider can freely adjust price without notice, or using users' content without notice. Or these are all considered as important using the website definitions. However, human contributor missed them. The GPT-4 does not. We use Gaussian fork index to measure the readabilities of the simplified text. And the original text result 24, which required more than a college graduate to understand that. In opposite, the simplified text result only 9, so a high school freshman can understand that. Also, the simplified text result a really high BERT score indicate that it can cover most of the information from the original text. The original text shown in the black colors have difficult vocabularies, complex grammars, and require read several times to understand. However, in opposite, the simplified text shown in the blue color are much shorter in length with no difficult vocabularies. One thing is that some definitions, such as the issues, what is the issues in the first example is not been defined by the simplified examples. We also train a baseline CNN models for unfair classification, but result only 20% F1 score, indicate that this model tends to classify samples into the most dominant classes, which is the fair sentence in these cases. In opposite, the fine-tuned GPT model result 90% in both accuracy and F1, which outperform the baseline model in both metrics. And the high F1 means that it's more resist to the imbalanced fair-unfair samples that is more fit to the real-world scenarios. And here are some examples that combine all three tests together. In these examples, there's two significant highlights, and each one are provided with a simplified text and the labels. The first label are labeled as unfair due to the Google can suspend you from their service. And the second one is labeled as fair, even if it highlights sentence. And that is the reason why we use two models to validate the results. From the result, the simplify and the classifying text shows a really strong performance since it have a really high clear ground truth and metrics. However, the text highlight, due to there is no 100% truth, does not show well in the metrics. In the future study, probably collaborate with legal profession to provide guidelines on how to evaluate the importance of the samples can be very useful for these projects. Thank you.